In this class, we're going to consider horizontal and vertical straight lines. So most questions about straight lines are not to do horizontal and vertical lines because they're less interesting. Their equations are different to the general y equals mx plus c equation of a straight line, and you just don't have as much that you can do with a horizontal and vertical line as you can with, say, another type of straight line. But to kind of fill out your knowledge about straight lines, we should look at them. They do come up sometimes, and they come up in other contexts as well, not just to do with a straight line topic, but they might come up in a different type of question, maybe to do with functions or to do with a calculus type topic. So let's just take a look at them. So they're fairly easy concepts to sort of work with. So we'll start with a horizontal line. So we're just drawing these on the normal XY axis. So let's say we've got a horizontal line which passes through some positive y coordinate like 3. So it's passing through the point 3 and it's just horizontal. Well, we know that if a line is horizontal, because it doesn't have any steepness, then it's said to have a 0 gradient. So we already know that the gradient of this line is 0. Just by definition, without even really needing to work it out, that line must have a 0 gradient. The other way that you could kind of think about that is if you took 2 points on the line, say a point there and a point there, and regardless of what their x coordinates are, they've both got a y coordinate. So some x coordinate, let's call it x1, and a y coordinate of 3, and then x2 and a y coordinate of, oh, sorry, not a y coordinate of y, a y coordinate of 3, then if we use our gradient sort of formula on those 2 points, because the y coordinate is 3 for both points, just plugging those into the gradient formula. So gradient, remember, is y2 minus y1 divided by x2 minus x1. Well, regardless what our x2 and x1 are, y2 and y1 are both 3. 3 minus 3 is 0, so this would come out to be 3 minus 3 equals 0 over some number, which doesn't really matter because 0 divided by any number is just 0. So that's how you could more formally recognize that that line, that horizontal line, has got a gradient of 0. But just by definition, it's got a gradient of 0 anyway. But we're not just interested in the gradient. I mean, we are interested in the fact that it's got a 0 gradient. In fact, we can use that, but we're more interested in the equation of the line. How do we write the equation of our horizontal line? So we know that straight lines in general have got the equation y equals mx plus c, where m is the gradient, c is the y-intercept. Just to kind of formalize this one a little then, we could say, right, our line is going to have equation y equals m is 0, so 0 times x plus c. 0 times x, of course, is just 0, because 0 times anything is 0. The c value, the y-intercept, is 3. So we just end up getting y equals 0 plus 3, which is 3. So it's a different format of straight line equation for a horizontal line. And in fact, in general, let's just take another horizontal line and we'll just say that this one passes through some point A. In general, the equation of a straight line, just extrapolating from what we've done there, is just going to be y equals whatever the y-intercept is. So if the y-intercept is A, then the equation would be y equals A. So basically, horizontal lines, 0 gradient because they've got no steepness, and the equation just y equals some number, and that number is the y-intercept. Okay, cool. Right, let's move on, have a look at a vertical line. Vertical lines are a little different. I would say vertical lines are even less popular than horizontal lines. They're more difficult to work with, as we shall see in a moment. So if we take a vertical line, and let's say that our line is going to pass through the point where x is equal to 4. So let's think about maybe the gradient, first of all, of this line. So you might already be familiar with the gradient of this line if you've studied gradients, but let's just take our 2 points. Now, let's not worry about what the y coordinates of those points are, but they're both on the line where x is 4, so they've both got an x coordinate of 4. So we'll just say 4, and we'll call that y2, and we'll say this guy is 4, and then y1 for the y coordinate. So if we go through the process of making the gradient for that line, so we're going to use y2 minus y1 divided by x2 minus x1. So we don't know what our y2 and y1 are, so we'll just leave those as y2 minus y1. But x2 minus x1, that's 4 minus 4. 4 minus 4 is 0, so we end up with some number on the top of that fraction divided by 0. But dividing by 0, that's the thing that gives you the big fat error message on your calculator. In other words, this here is an undefined operation. We don't define dividing by 0, so that basically means that the gradient of this line, the m value, so the m value is undefined. So this line doesn't have a gradient, but be really careful because a lot of students will make the mistake of saying it doesn't have a gradient, therefore the gradient is 0. It's not a gradient of 0, that one has got a gradient of 0. This one just doesn't have a gradient at all. By definition, it has no gradient, okay? So be careful with that distinction. That's a really common error. So how then do we take that forward and still get an equation of that line? Because here we use the fact that the gradient was 0 to then derive the equation of a horizontal line. How do we derive the equation of a vertical line? Well, it's a little kind of less formal than we've done over here. We just basically say, right, what do we know about this line? Well, the only thing we really know is that every point on the line has to have an x coordinate of 4, because it doesn't matter where you are up and down this line, because it's exactly vertical, every point is stacked above each other, so they've all got an x coordinate of 4. So we just basically say, it's a little bit of a cop-out I think maybe, but we just basically say the equation of that line is just x equals 4. Okay, and that is basically what we do for vertical lines. So if you then take some just general vertical line there, which has got an x coordinate of a, so all of the points have got an x coordinate of a, then unsurprisingly, just to kind of match what we did here, the equation of that vertical line would just be x equals a. So it's just x equals whatever the x coordinate of any point on the line is. So you only need one point on the line. If your point was here, or it could be the point right on the x-axis, or it could be down here, they've all got the same x coordinate. So a in this case, so the equation of that line is just x equals a. So you can see why vertical and horizontal lines are a little bit icky. They don't really allow you to do much with the equation of a line in the sense that you would normally work with the equation of a line. That's why they tend to be less popular question types. You will see this one in other topics. For example, it forms a line of symmetry on a parabola and other types of graph as well. So you might see it in that context. This one, a bit more random really, might just pop up in some questions, maybe as a tangent line to a curve or something like that. So just basically take away the notion of this having a 0 gradient, this having an undefined gradient, that being the equation of a horizontal line, and that being the equation of a vertical line. So that's pretty much how we work with straight lines that are horizontal and vertical.